Hi everyone, good morning. I hope you attended yesterday's mock test, and what I saw, like from the question paper, what I understood is that it was a little bit tough question paper because not because of all the questions were tough, it's because of the first few questions. Okay, first few questions you might like feel difficulty solving that, and that might affect your like confidence level, and that will further move on to other questions also. Later questions are easy, even though that is there. Initial questions might make you panic. Okay, so that you have to expect in all the entrance exam, that first few questions they might give them like very tough ones, so that like they will test the confidence level of students. So when you are trying to solve the first question and it's not happening, what we have to do is we have to move on to like just skip it and try to find a question that you can solve easily. Do that, bring your confidence level up, then we can solve the other questions. Okay, so in this one, this is from semiconductors chapter, which we will be covering tomorrow, and in that they are saying that in the these are energy band diagrams. EC represent the lowest energy level of the conduction band, EV represent highest level of valence band, ED denotes donor energy level, and EG is the forbidden energy gap. Which of the following band diagrams is correct for N-type semiconductor? Okay, so they are asking about N-type semiconductor, and what is the property of N-type semiconductor? Number of electrons will be more, like majority carriers will be electrons. Okay, and for semiconductors the condition is that there will be conduction band, there will be valence band. For a like material to be conducting electricity, the condition is there should be electrons in conduction band. Okay, so as you can see in these, there are four diagrams given. In the first one, this is conduction band, this is valence band, this is the donor energy level, and there are so many, and black ones are electrons, white ones are holes. They already said that. So in conduction band so many holes are there. Okay, so that is not the case in N type. Here more electrons are there, but in valence band and only one hole is there. Next you can see here also one hole is there. Last one you can see that, sorry, actually what have they given? White circles represent a hole. Okay, are they asking about? Oh, okay, sorry, I inverted the sorry for the misunderstanding. I inverted the PDF color. So here white hole means electrons and black hole means holes. Okay, so here number of electrons is more, but donor energy level is given here. Here one electron is there and rest like electrons and holes are present in the valence band, and donor energy level is here. Here they have given that donor energy level is in the middle of the energy gap and one electron present. Here you can see that number of electrons is more and donor energy level is near to the conduction band. So that is what happened when we are making N-type semiconductor. We are using pentavalent impurity, right? So it will have more energy. That's why its electron can be in conduction band. Okay, so this is the correct answer, option D. I hope it's clear for all. In this particular thing I have in like reverse the color, that's why white is electron and black is holes. Is that clear? Okay, moving on to next question. In a Young's double slit experiment, while using white light, the slit separation D is given as 1 millimeter and screen distance D is 2.5 meter. Which of the following wavelengths will be missing or having destructive interference at a point on the screen directly in front of the directly in front of one of the slits? Okay, this is the question. Like sorry that you guys had KCT and you were not able to attend our previous class. In wave optics class actually we did a similar question. Okay, this you don't have to go into direct equation, we have to be in the starting of the derivation, okay, from the path difference. Path difference is delta x. Delta x we are finding using equal to d sine theta formula. In this, then we are putting the assumption that sine theta is approximately equal to theta, and from that we are getting this is equal to dy by d. Okay, this is path difference. Path difference delta x equal to small dy by capital D, and I will explain what these values are. This distance is d and this distance is small d, and from the middle to the point which we are taking, this is y. Okay, I hope you understood the variables here. Now this is our path difference, and the condition for destructive interference is that path difference should be equal to, for destructive interference, path difference is equal to 2n minus 1 lambda by 2. Putting this condition, actually we are getting equation for y equal to, but instead we have to solve for lambda here. Okay, so path difference, this equation is there, this equation is there, equate them together. So you will get dy by d equal to 2n minus 1 lambda by 2. From this solve for lambda. Lambda equal to 2 dy divided by d into 2n minus 1. In this, small d is given, capital D is given, y they are saying it is directly in front of one slit. So y equal to d by 2. So all the values are given. Now substitute it, find 2 dy by d and divided by 2n minus 1, keep it like that. This when you solve, you will get lambda equal to 400 divided by 2n minus 1. Okay, then substitute n equal to 1, n equal to 2, like that we can substitute. So when you substitute n equal to 1, this is equal to 400. When you substitute n equal to 2, this is 400 by 3. That value is not present in the options. So we can go with the first option, that is 400 nanometer. Is it clear? Okay. Do you have any doubt in this one? We are using the path difference equation here, and condition for destructive interference for path difference. We are equating them together and solving for lambda. Is it clear? Just give me a thumbs up. Okay. Moving on. So next one, third question number 3. A series LCR circuit containing a resistance of 120 ohm has angular resonance frequency 4 into 10 to the power 5 radian per second. At resonance, the voltage across resistance and inductance are 60 and 40 volt respectively. What is the value of inductance L in the circuit? So you have to find what is the value of L. So in case of resonance, what is the thing that XC equal to XL? This is the condition for resonance, okay, which means capacitive impedance reactance equal to inductive reactance. In that case, the potential drop between them will be same, right, because it is series. So R C L, they are connected in series, current through them will be same and their reactance is same. In that case, potential across these both will be same. So first you need to know that basic thing. So total potential is equal to potential across R plus potential across total potential will be equal to root of VR square plus VL minus VC the whole square. Okay. This will be our total potential. This is basically equal to what? This is equal to VR, which means if you want to find current I is equal to VR by R, because XC and XL is cancelling each other because of resonance. From this you will get I equal to what? 60 divided by is R given? Yes, 120 ohm. So 60 by 120 ampere. This is our current. Okay. Now we can find what is the reactance XL. Since VL is equal to 40, VL by I will be equal to XL. Substituting this I here, you can find XL. And what is XL? XL equal to L omega. Okay. So first we will find current from resistor, then we will substitute that I in inductive like potential across inductor and find inductive reactance. Inductive reactance is equal to L omega. Substituting the value, we will get option C. Okay, 0.2 millihenry. Is it clear? Okay, good. Moving on. A balloon starts rising from the ground with an acceleration of 1.25 meter per second square. After 8 seconds, a stone is released from the balloon. What is the time taken by stone to reach the ground? Okay, so this is the question. In this, we don't have to use anything else, just basic like equations of motion we have to use. Okay, balloon starts rising from the ground from initial acceleration 1.25 meter per second square. Okay, so this is the acceleration, and after 8 seconds a stone is dropped. So after 8 seconds we have to see what is the velocity of the balloon and also what height it is there. To find height, it is easy. S equal to ut plus half at square. Initial velocity is 0. Acceleration is given. So S equal to 1/2 8 square. Okay. On substituting the values, you will get after 8 seconds what is the height of balloon. That you will get as 40 meters. So from ground it reached 40 meters. From this, here the stone is dropped. Okay, stone is dropped from here, but stone is having an initial velocity, right? Because it was moving up. So finding the initial velocity of like stone, we have to find final velocity of balloon at 8 seconds. So V is equal to U plus AT, and U is 0. So VF equal to 1.25 into 8. This you will get as, will we not add A and G for balloon? No. Why? Because balloon, they are like assuming it to be weightless. Okay. The reason is like we are not separately considering is they are already giving the value of acceleration, how it is accelerating upwards. So they have already included G in that. That's why we are not separately adding it. Okay. And if you want to add G, the mass of balloon is also not specified. So we don't have to add that. Okay. So here it will be equal to 10 meter per second. If they have directly given like this, use that value only. Okay. In case of lift and all, you have to use G also. So from here we get final velocity also, then distance also. Then we can use what we have to find, time taken by stone to reach the ground. So for stone we have to use S equal to ut plus half 8t square again. In this t we have to find s equal to minus 40, u equal to 10 plus half a equal to minus g. Since initial velocity is in upward direction, I took that as positive. So everything in downward direction will be negative, t square. After substituting these values and solving for t, you will get two values. One is minus 4 and one is 2. So answer will be, sorry, minus 2 and 4 you will get as options. So time cannot be negative, then answer will be D, 4. Okay. This is a quadratic equation, that's why you are getting two solutions. I hope you understand that. Okay. Next one, a fixed non-conducting ring of radius r carries uniformly distributed charge q. An electron of mass m charge is released from rest at distance x equal to root 3 r from the sender. What is the maximum speed attained by the electron? Okay, so here they are asking about speed. So basically speed depends on two things, that is distance and time. If we can calculate force on the charge, and from that we will get acceleration, but we need time to get the maximum speed, right? So instead of that, whenever such cases are there, you have to keep this in your mind. Whenever you have to calculate speed but nothing related to time is given, then use the equation of conservation of energy. Okay, conservation of mechanical energy use here. So initial kinetic energy plus potential energy is equal to final kinetic energy plus final potential energy. Since no time is mentioned anywhere, we have to use this equation. And see here, initial kinetic energy, it's starting from rest. So initial kinetic energy is 0. To find potential energy, we have equation for ring. Potential energy equal to kq by root of r square plus x square. So potential energy u will be equal to, this is our electron, so minus e kq divided by root of r square plus x square. This will be potential energy. Initial one, you substitute x equal to root 3r and substitute it here. Final kinetic energy is the maximum one, right? It will be maximum whenever force becomes 0. Where the force becomes 0? At the center of the ring. So final kinetic energy is half m v max square. This v max is what we have to find. And potential at the center of the ring is equal to k minus kqe by r. Okay, so this will be minus kqe by r. Substituting these values, you can solve for v max square. Is there any doubt? Answer is option A. Okay. I hope it's clear for all and we can move on to the next question. Next one, the escape velocity from the surface of planet is independent of angle of propulsion. You know the formula for escape velocity, that is equal to root 2 gm by r. There nowhere we are talking about angle of projection. Okay, so it is independent. Statement 1 is true. Statement 2, gravitational potential is a vector quantity dependent on the path taken. Is it a vector quantity? Potential is a scalar quantity. We already know that. Potential, dimension of energy, scalar quantity. So this is false. Answer is A. Statement 1 is correct, but statement 2 is incorrect. Okay. Next one. A vertical spring of force constant K is suspended from mass m. Time period of oscillation is T. It is then cut into two parts where length of one part is 3 times the length of other part. Ratio 1:3. Longer part is now suspended from the same mass m. New time period T dash will be. See here small like structuring mistake is there. Spring is not suspended from the mass. Mass is suspended from the spring. Okay, so some grammatical error. And one thing you need to know is K is proportional to 1 by L, length of the spring. So if it is cut into two springs, total K1 by K2 will be then L2 by L1. It is cut into 1:3 ratio, right? So L2 by L1 will be equal to 3. So you get an idea about K1, K2. So K1 equal to 3 K2. So we want to find for longer part, right? Which is longer part? K2 is longer part. So for K2 we have to find. Then you can use K will be equal to like when we are cutting, it is separating, right? When we are joining it back together, it will be like two spring in series. Two spring in series means K effective will be equal to K1 K2 divided by K1 plus K2. Substitute for K1 from this and you can get K2 in terms of K. Substitute that in the equation. Time period equal to 2 pi root m by k. This is for first case. New T dash you have to find. You have to write 2 pi root m by K2. Okay, in this K2 when you substitute in terms of K, you will get T dash in terms of T. Okay, when you substitute, you are going to get answer T dash equal to root 3 by 2. Okay, root 3 by 2T. Understood? First find this relation between K1 K2, substitute it in here to find K in terms of K, then find time period. Do you have any doubt in this? So, okay. Next one, conducting rod of length 1 meter rotates with a constant angular velocity of magnitude omega equal to 10 radian per second about. One of it ends in in a plane perpendicular to the uniform magnetic field B equal to 0.2 Tesla. Other end of the rod touches circular conducting ring. Wire connects the center of rotation of ring. Total resistance of the circuit is 2 ohm. Find the thermal power dissipated in the circuit. Okay. Power equation is nothing but V square by R. Resistance is given. V we have to find. So something is rotating in magnetic field, induced EMF will be there. So power is equal to induced EMF square divided by R. How to find induced EMF if something is rotating? If something is rotating in a magnetic field, then its equation is quite straightforward. You don't need anything else. It will be half B R square omega. R is the radius. Okay. This is the formula if anything is rotating in a like magnetic field. It can be like one rod rotating. It can be two rod rotating, or it can be a disc rotating. Formula will not change. It will be this formula only. Okay. So sometimes you will see a wheel with 8 spokes are rotating. Same formula. You don't have to multiply it with 8. Okay. So all these things are given in the question. Directly substitute and then substitute it here. You will get the answer. C equal to 0.5 watt. Okay. Do you have any doubt in this? Okay, then let's move on to next question. Next one, match the transition of hydrogen atom in list 1 with corresponding spectral characteristics in list 2. This I already I don't know if you have attended the modern physics class. In that we did a similar question. When you get things like this, do only one thing. Choose the highest difference in N1 N2. That will have shortest wavelength. Okay, highest different N1 N2 will have maximum energy, shortest wavelength. So here N2 infinity, N1 1 maximum difference, and N1 equal to 1, that is Lyman. So shortest wavelength of Lyman series from 1 to 8 to 3 we all first get. Then check the option. Only one option is having that answer, so you can directly find it. Now let's say like 2 options are having it. Then you can check one more thing, that is like shortest gap, maximum wavelength. Shortest gap, minimum energy, maximum wavelength. Here shortest gap is between 2 to 3, right? 2 to 3 is shortest gap. So B will be, and N1 equal to 2 is Balmer series. So you can see longest wavelength of Balmer series, B1. So that is also there. Like this you can just with the 2 values you can get the correct answer. You don't have to solve anything. Okay. Even if values of wavelengths are given like 400 nanometer, 620 nanometer, like that values also given, you can compare. Maximum value will be for this only, minimum value will be for minimum distance, like that. Okay, is it clear? Okay, moving on. A uniform wire of cross section area A, weight W and initial length L hangs vertically from a fixed support due to its own weight. The wire stretches by total length L, value of L by L. So this depends little bit on our integration. Okay, it depends little bit on that. So if you are not comfortable with integration, I would suggest that you skip such questions. So here how we have to solve is, see, this is our initial rod. Okay, wire of cross section area, weight W, total weight W, length L. So we have to first find mass per first we have to find mass per unit length. So total length is L, total weight is W. So we can say weight per unit length W is equal to capital W by L, which means if you take a small portion, what will be unit length of that material, what will be its weight, that is this. Okay, now we are taking a small element dx at x height. Okay, at x distance we are taking a small element dx. Because of the weight below it, it will stretch, right? It is stretching by dl amount. Okay, and what is the weight of this thing? That new weight will be dw will be equal to w by l into x. Okay, this is the weight which is making dx stretch. Okay, here force is equal to dw, weight of that extra thing. Area, there is no change, A. Then Young's modulus is y. Strain will be equal to like initial length dx, final extra length dl. So strain will be equal to dl by dx. Okay, so you will get strain is equal to what? Strain is equal to F by A y into Young's modulus. So strain equal to force by area into y. From this you will get dl by dx is equal to forces dw, that is w x by l into a into y. This you will get. Now dx is here, dx is here, bring it to this side. dl is equal to w a l y x dx. Now integrating on both sides, here from integrating from 0 to L, we are starting from this point to maximum length L, you will get L equal to, this will be x square by 2, so w a l y x square by 2 from 0 to L. So L square by 2 will come, L will get cancelled, and you can bring L to this side. So you will get L by L is equal to W 2 AY. So you have to find capital L by small l. So find reciprocal. Answer will be option C. Did you understand? It is a bit lengthy and you have to like derive the whole equation. So it might not be, I wouldn't suggest like this is the easiest question to solve. If you are not able to solve, just skip it. Okay. Can we move on then? Okay. Next is binding energy curve. Okay. Binding energy curve. In this, what we are plotting? Binding energy per nucleon. Total binding energy divided by mass number and mass number. According to this we are plotting. Question is very direct. According to the graph, binding energy per nucleon versus mass, which of the following possess minimum binding energy per nucleon? Minimum binding energy at this point, that is deuterium. So option B is the answer. Okay. Option D, deuterium has the minimum binding energy per nucleon. So we can move to the next question. That is, an ideal gas undergoes with isochoric process. Which of the following graph correctly represent this process? Isochoric means volume constant. So from ideal gas equation we will get P proportional to T. P is directly proportional to T, which means it will be a straight line graph. So this is correct. Okay. Now if you see here, they are plotting 1 by T. If you are taking 1 by T, 1 by T is proportional to 1 by P. So the graph will be of 1 by P. Okay. So this graph is also correct, which means option D, both B and C correct. Is it clear? If you have confusion, put 1 by T equal to X and P is equal to Y. We know that like X proportional to 1 by Y. So graph will be of like reciprocal, that 1 by X graph. I hope you can identify with that. Next, work function of a metal surface is given as 2 electron volt. Light of wavelength 310 nanometer is incident on the stopping potential is. So already they have given Hc in electron volt, so you can find easily. Stopping potential into E is equal to maximum kinetic energy, which is equal to Hc by lambda minus phi. This is our formula. Okay. So kinetic energy max we don't have to find, directly equate it. So EV0 is equal to Hc, that is 1240 divided by 310 minus 2. So here E is not required. Why? because it is already in electron volt. So we can directly put V naught only. Okay. When you substitute these values, this you will get as 4. 4 minus 2, 2 volt. Answer is 2. Okay. There is no much numerical calculation happening here. Next one. A parallel plate capacitor with air as medium has capacitance C naught and is charged to potential V naught. The charging battery is then disconnected. Now dielectric slab of dielectric constant K is inserted, which fills the entire space. Work done by external agent in inserting the slab. So work done you have to calculate. Work done is what? It is like potential energy, right? Change in potential energy in this case. Like from work energy theorem, both are correct. Work done equal to change in kinetic energy, but if it's a moving thing, or work done equal to change in potential energy when potential energy is changed. So you can just find what is the change in energy. Energy equal to half CV square. This is our formula. Even if you can directly connect it, see the options. It is in CV square formula. So you can directly use this. Initial case, we can say initial energy is equal to half C naught square, C naught V square, V naught square. Okay. Now what we are doing, we are disconnecting the battery. So potential will not stay constant. We are inserting the dielectric, but charge will stay constant. Okay. Here initial charge Q naught equal to C naught V naught. Final charge Q is equal to Q naught only, but given by what? Nu C and nu V. Nu C, like K dielectric is inserted, so nu C is equal to what? That is equal to K C naught into nu potential we don't know. This is equal to C naught V naught. Cancel C naught, we will get V equal to V naught by K. So final energy is equal to half CV square, half C is K C naught, V naught by K the whole square. Okay, substituting this you will get this is equal to C naught V naught by 2K. You got final energy, initial energy, substitute the value of K, find the difference, you will get the answer. Okay. Since we are doing final minus initial, answer will be negative value. Okay. Answer will be negative value because we have to find final minus initial. Final energy will be less than that of initial energy. So answer is option A. Is it clear? Okay. Let's see the next question. Phase difference between velocity and acceleration is pi by 2. That is true because velocity is equal to a omega cos omega t and acceleration is equal to minus a omega square sin omega t. So sin and cos is there. Phase difference will be pi by 2. This is true. Okay. Then statement 2, average kinetic energy in one complete time period is equal to average potential energy. We know that total energy is constant. Kinetic energy and potential energy are kind of like inverse to each other. So their average will be same only. So this is also true. Third one, frequency of oscillation of spring mass system is independent of acceleration due to gravity. We know for spring mass system, time period equal to 2 pi root m by k. There is no g in the formula. So this is also true. Answer is option D. Is it clear? If you have any doubt or need much more clarification in any question, you have to ask, okay? Otherwise, I will assume that you understood it. Next one, a uniform rod of mass m and length L is hinged at one end to a vertical wall and held horizontally by string attached to the other end, tied upon the wall vertically above the hinge. Angle between rod and the string is 30-degree, tension in the string. So we have to find the tension. Since this is the rod, at the center of mass mg will be acting downwards. So if we cut the string, what will happen? It should rotate. It is fixed at this end, so it will rotate, right? Which means a torque is there, and this string is cancelling out that torque. Tension we can split into components, so this will be T sin 30. This component is cancelling out the torque from this thing. Okay, so because of mg, torque due to mg cancelled out by torque due to tension sin 30. Okay, this is the concept we are applying here. Torque due to mg, force into perpendicular distance equal to L by 2, which is equal to torque due to tension equal to T sin 30 into perpendicular distance equal to L. LL cancel, sin 30 1 by 2, so T equal to mg you will get. Answer is option D. Everybody understood this? Okay. Moving to the next question. A uniform circular disc of mass m and radius r is rotating about an axis passing through the center and perpendicular to its plane. A circular hole of diameter r is cut out from the disc and center of the hole is at distance r by 2 from the center of disc. Moment of inertia of remaining part of the so moment of inertia of remaining is equal to moment of inertia of whole thing, like before cutting, minus moment of inertia of whole with respect to axis of rotation. This is the formula. You have to remember it like this only, because if you just name it like I1 or I dash, you might not understand what it is. So remaining portions moment of inertia is equal to whole thing's moment of inertia minus moment of inertia of cut region, but with respect to what? The axis of rotation. Okay, so this is the whole thing. So moment of inertia of whole thing disk is equal to m r square by 2. Okay, now if you want to find moment of inertia of this hole, okay, this is the circle. At r by 2 there is a hole with r by 2 diameter. Okay, diameter r, okay, r by 2 radius. So this is the hole. So if you take just the hole, let's say this is the whole part, and through the middle it will have, let's say, mass m, radius r. Its moment of inertia with its center of mass is equal to half mr square, like mr square by 2 directly. That will be axis with respect to here, but actual axis of rotation is here, right? So with respect to that we have to find. So I of whole with respect to axis of rotation is equal to this ICM plus md square. Okay, md square. This distance is d. This is our parallel axis theorem that we are applying. So ICM equal to small m r square by 2. We don't know mass of this. To find mass of this, we have to take total mass equal to m divided by total area equal to pi r square. That is total density. Small mass is equal to this into area of this, that is equal to pi r by 2 the whole square. From this you will get m equal to m by 4. Substitute it here, m by 4 into 2, then r square by 4. This will be ICM. So with respect to whole, it will be equal to m r square by 32 plus this is equal to m by 4 into r square by 4. So m r square by 16. This will be moment of inertia of hole with respect to axis of rotation. Substitute it here, you will get m r square by 2 minus m r square by 32 plus m r square by 60. This will be our answer. Is that clear for all? Formula is simple, but like so many steps will be there in the calculation. Like if you are having doubt, please ask me like which I should explain more. Okay, then I think like nobody is having any doubt, we can move on. Next one, a prism has a refracting angle 60 degree, it produces a minimum deviation of 30 degree refractive index. Direct formula, refractive index equal to sin a plus dm by 2 divided by sin a by 2. This is equal to sin 45 divided by sin 30. Sin 45 1 by root 2, sin 30 1 by 2. So answer will be 1 root 2, which is option D. Okay, is it clear? Okay, moving on to next one. A string of length L fixed at both ends vibrate in its fundamental mode with the frequency f. If tension in the string is increased by 44%, length is reduced by 20%, new fundamental frequency will be. Okay, velocity of like wave in string is equal to root T by mu. T is tension in the string, mu is mass per unit length. If you cut the spring, mass per unit length is not going to change. So mu will remain constant in this case. Okay, and fundamental frequency we are finding using like V by nu is equal to 2L. This is the formula. Okay, so or F we can use if you want. Okay, V by F equal to 2L. So F is equal to V by 2L. This is the formula. V is velocity, L is length of the spring. Substituting the equation of V, we will get T by mu divided by 2L. Now for new frequency F dash, what we are doing? Tension is increased by 44%. So new tension will be equal to T into 1 plus 44 by 100. T plus 44% of T. Okay, and this will be equal to 144 by 100 T. Since it is inside the root, when we take outside you will get 12 by 10 root T by mu. Okay, I am skipping steps, so if you don't understand you should ask me. Next is length. Okay, new length is equal to L dash is equal to 20%. So L into 1 plus 20 by 100. Sorry, reduced. So L minus. Okay, 1 minus will come, and this is equal to 100 minus 20, 80 by 100. Okay, so 80 by 100 into 2L. Now this thing is our F. Just calculate this value, you will get what is the new frequency. Okay. Then you will get answer as 1.5 F. But mass per unit length, are we not considering length there? See, mass per unit length is like for this pen, like total mass is 10 kg, 10 gram. Length is 15 centimeter. Mass per unit length will be 10 by 15, right? Now let's say I am cutting it into two parts. Two parts means one part will have 5 gram and length 7.5. So 10 by 15 is equal to 5 by 7.5. Even if I cut, that value is not going to change. Understood? Yes. So that's why mu will not change. Okay. Next one is solenoid of length 50 centimeter and area of cross section 10 centimeter square has 500 turns. A current of 2 ampere is passed through it. Magnetic energy stored in the solenoid. Okay. So we have one equation, that is like magnetic energy, how to find magnetic energy density. So energy density is equal to B square by 2 mu naught. This equation is there. How we are getting this equation? Comparing to electrical energy density E square epsilon naught by 2. Comparing to this, we are having this equation, but that is energy density. So total energy will be equal to this energy density into volume. Volume equal to area into length. So B square by 2 mu naught into A into L. One, you can use this equation, or you can use the equation energy is equal to half L I square. Okay, here B is equal to mu naught N I by L. So either you can use this method or you can use this method. This is half L I square. L is mutual inductance. Mutual inductance value L equal to mu naught N square A by L. So either one of this method you can use and find the answer. Okay. Do you have any doubt in this? Okay. Moving on. Sorry, I didn't note down which option is the answer. Next one. A disc rotating about its axis from rest with constant angular acceleration acquires angular speed of 100 revolution per second in 4 seconds. Angle rotated by it during these 4 seconds. Okay, so for rotational motion also, while we studied the chapter, I told you we have the same formula as linear motion. Okay, so if you want to find angle, you can use this equation. Omega f square minus omega I square is equal to 2 alpha theta. This you can use. Okay, or you can use which equation? Theta equal to omega I t plus half alpha t square. That also you can use. Here maximum angular speed is said to be 100 revolution per second. This 100 revolution per second is actually frequency. In per second, how many rotations are there? So omega f is equal to this 2 pi f. You can find final omega. Once you get that, initial omega is 0. So you can directly substitute it and find what is s. In this, you want to find alpha also. Okay, alpha, how you can find? T is given, right? 4 seconds. So you can find that alpha t equal to omega f, or like actual equation is omega f equal to omega I plus alpha t. Omega is 0, so alpha t. and omega f by 4 second equal to alpha. So you can find omega alpha, this is 0, then substitute and find theta. Do you have any doubt in this? No. Answer is option D, 400 pi. Okay. Yes, correct. Next one, trajectory of a projectile in a vertical plane is given by equation pi equal to root 3x minus 2x square, where x and y are in meters, angle of projection theta and maximum height h attained respectively. So for solving this, just by knowing our projectile equations for h, r and t is not enough. You need to know trajectory equation also. Trajectory equation we usually get as pi equal to x minus g u square sine square, g u square by u square, not u square, g x square by 2 u square cos square theta. Okay, this is the formula for trajectory of a normal projectile motion. How we are getting that, like if you have doubt regarding that, please go and refer to the topic. Now we don't have the time to explain it completely. Now from this you can see this term is having x square. This term is x into tan theta. Comparing to that, we will get tan theta equal to root 3, which implies that theta equal to 60 degree, right? So we can cancel out two options, A and C. Theta should be 60 degree. Now we have to find h. Okay, for h we have this equation, h equal to r tan theta divided by 4. This also you can easily this equation you can easily derive using relation, if you know relation between h and r. Then yes, correct, Supriya, answer is option D, h equal to 3 by 8. Okay, anyone have any doubt regarding this trajectory equation? Please refer to the chapter if you have doubt, and this one you can easily derive using h equal to and r equal to with formula. Okay, next one, in series LCR circuit, voltage across resistance, capacitance, inductance are 10 volt. If the capacitor is removed, voltage across the inductance will be. So as I told you, total voltage is equal to root of VR square plus VC minus VL the whole square. If you remove VC, then it will be equal to what? V dash is equal to root of VR square plus VL square. Okay, since VC equal to VL in this case, all are 10 volt, this V is equal to just 10 volt. Okay, and since from this only we can say that R equal to XL. In that case, when we connect it again, it will be split. V1 and V2 will be same. So here we can write it as root of 2 VL square, which is equal to root 2 VL is equal to this 10 volt. Okay, so answer is 10 by root 2, option C. Okay, is it clear for all? All are having equal volt. So first we find what is the total volt. Yes, so everything is having equal potential drop. So first we find total voltage in the circuit, that is 10 volt they are giving. Now since each are having equal voltage, like VR equal to VL we can write. and same current is going through that, right? VR is equal to IR and VL is equal to I into XL. I cancel, from this we will get that R equal to XL. So I can just write in new case VC is not there, so it will be root of VR square plus VL square. Since R equal to XL, the potential drop between them will be same if we remove capacitor also. Then instead of VR, I will write this as VL square only. Then root 2 VL square will come, VL will come, total potential. Voltage across inductance only we have to find, right? So VL we will get 10 by root 2. Now is it clear? Okay. Next is, during an adiabatic compression, 830 joule of work is done on 2 moles of diatomic gas to reduce volume by 50%. Change in its temperature is nearly. So here is the keyword, change in temperature only we have to find. Work done for adiabatic cases NR T2 minus T1 or T1 minus T2 divided by gamma minus 1. We don't have to find T2 or T1. If we have to find T2 or T1 only, we have to think about that volume. Here we don't have to think, because this delta T only we have to find. This we can write NR delta T divided by gamma minus 1. Delta T we have to find, so work into gamma minus 1 divided by NR equal to delta T. Work is given, okay, number of moles is given, R value is given, only gamma we have to find. Since it's a diatomic ideal gas, F is equal to 5, gamma is equal to 1 plus 2 by F. So gamma is equal to, substitute that here, minus 1, so it will be just 2 by F, which means it is equal to 2 by 5. Okay, yes. So substituting that, you can easily find answer is equal to C, 20K. Is it clear for all? Okay. Moving on. Next is screw gauge. I think the same question we did in our PYQ when we were doing the chapter units and measurements. Same question we did there. So we have main scale reading 0 millimeter, circular scale reading 52 divisions. 1 millimeter on main scale corresponds to 100 division, means number of division in circular scale is equal to 100, and pitch is equal to 1 millimeter. Okay, in that case least count is equal to 1 by 100 millimeter, that is equal to 0.01 millimeter. Least count we got, we can find total reading, then convert it to centimeter, you will get the answer is equal to 0.052. Clear? Okay, then we can see the next question then. Okay, next one. A positive charge Q is uniformly distributed on a metallic sphere of radius R. If the potential on the surface of sphere is 20 volt, potential difference between point X and Y. The thing we have to know is metallic sphere. Metallic sphere means only charge will be there on the surface, which means inside potential will be same as on the surface. So potential at X is equal to potential at the surface, which is equal to 20 volt. Okay, and at Y potential is equal to what? KQ by distance R. Distance R is equal to 2R. Okay, so KQ by 2R. On the surface, what is the charge? Potential at the surface is equal to KQ by capital R. This is given as 20. So this should be equal to 20 by 2, 10 volt. Difference will be 10 volt. Okay. It is a very easy question. think we can move to the next one. A weightless ladder of 20 meter long rests at a frictionless wall at an angle of 60 degree from the horizontal. A 150 kg man is 4 meter from the top of the ladder. A horizontal force is needed to keep it from slipping. Choose the correct magnitude of force. So again we have to use that torque method we didn't know. That same method we have to use. See, this is the ladder. At 4 meter from the top means here is the man. So 150 G acting downwards here. This distance is equal to 16 meter. This is 4 meter. Okay, and angle have they given? Okay, angle is given as 60 degree here, and they are saying a force is required to applied horizontally so that it is not moving. Okay, if we are using that, we have to see, like in this wall normal force will act in this direction, right? That normal force will be equal to the frictional force acting horizontally, because all horizontal and vertical forces should be equal to each other. Okay, so normal force is acting here also. This and this will actually cancel out if you are taking in linear way, and this friction and or this external force and this n will cancel each other out. Now we have to see the rotation way. So we can get that n equal to F. This F we have to find. Now for torque due to man should be equal to this. Here we don't see the torque because this we are considering as the axis. So perpendicular distance for the point of application of force is 0. So there will be no torque due to these two. Torque will be due to these two. Torque due to man should be equal to torque due to N, normal force. Torque due to man 150 into G, 10. Like 10 we don't have to apply, because if we multiply with 10 A, you will get like in Newton force. But here it is in kilogram weight, so we don't have to multiply this 10. Force into perpendicular distance, right? Similar way here also, force into perpendicular distance. For this we have to see. Here if you see, this is the point, okay? So perpendicular distance is equal to 150 into 16 cos 60. Okay, this distance is perpendicular distance, and for here this distance is perpendicular distance. Okay, so here it will be FL, total length, that is equal to 20 into sin 60. 50 16 cos 60 equal to 1 by 2, 20 sin 60 root 3 by 2. F we have to find, substitute all the values, you can get that final answer is equal to 69.2. Root 3 you can substitute 1.772 and calculate. Okay, I hope you understand this problem. Okay, then let's move on to the next question. A constant voltage of 50 volt is maintained between points A and B of circuit shown in the figure. Current through CD. This question also we did in current electricity PYQ. Okay, do you remember that? Same question we did in PYQs. Yes. Okay, so first we have to find total current in the circuit. If you get the current, I1 is passing through here. Here I minus I1 will pass. Here I2 is passing. So here will be I1 minus I2. If you can find I1 and I2, you can get the answer. Okay. First find I. I is equal to 50 divided by R equivalent. So first you have to find equivalent resistance. R equivalent, how you will find? This is 1 ohm, 3 ohm, and then there is 2 ohm and 4 ohm. So this is our R equivalent circuit. You have to find R equivalent. Then I1 will be equal to I into 3 divided by 1 plus 3. Similarly, I2 will be equal to I into 4 divided by 2 plus 4. You will get I1, I2. This is equal to 18. This is equal to 16 ampere. And I is equal to 24 ampere. So I1 minus I2 is the current we need. This is equal to 2 ampere. Answer option B. Okay. Do you have any doubt in this question? No. Okay. Next, force acting on a particle depends on time t according to the equation this. What are the dimension ratio of alpha, beta by alpha? So alpha dimension of alpha t minus 1 should be equal to dimension of f should be equal to dimension of beta t square. Okay, dimension of f is equal to m1 l1 t minus 2, that is equal to dimension of alpha into t minus 1. When you cancel this dimension of alpha, you will get as m1 l1 t minus 1. Similarly, you can find for beta. Beta you will get as m1 l1 t minus 4. Okay. Then beta by alpha if you take, you will get as t minus 3. m0 l0 t minus 3. Okay. Any doubts? Okay, then let's see next question. A star initially has 10 to the power 40 deuterons. It produces energy via this process. If average power radiated is 10 to the power 16 watt, deuteron supply of the star is extorted in time in the order of what? Okay. So all the values are given. In this reactions, if you see how many deuterons are using, 1, 2, 3. Total 3 deuterons. Okay, this product of tritium is directly taken here, so we don't have to consider that. 3 deuterons producing 1 helium plus neutron plus a proton. So this reaction we can write as 3H21 producing helium plus proton plus neutron. Okay, this is the formula. Now to find how much energy is produced by this, you have to use 3 into mass of deuterium minus mass of helium plus mass of proton plus mass of neutron. This is delta m, mass defect. Okay, then energy is equal to delta m c square, or since everything is given in AMU, you can just multiply delta m into 931 mega electron volt. You can get this value, but this is in electron volt, we have to convert it to joule. So energy is equal to delta m into 931 into 1.6 into 10 to the power minus 19 into 10 to the power 6 joules. Okay, this you will get energy. Okay, this is energy per reaction. Now you have to find average power radiated is 16 watt, which means in 1 second this much energy is released. Okay, so one reaction is giving this much energy. So n number of reaction will give this much energy. So find E. N is equal to 10 to the power 16 by E. This is number of deuterons used per unit second. Okay, per unit time how much deuterons are being used. Now you have to find time, right? Total time for exhausting. Then you will have to use 10 to the power 40. Total number of deuterons divided by N. You will get what is the time taken for exhaustion. Here you will only need to use the 10 power. Okay, so do a rough calculation only. Don't do like exact value calculation, because options you see only 10 power is required. So do an approximate calculation and find the power of 10 accurately. Substitute. You will get the answer option C. Okay, answer is option C here. Make sure that you are able to solve this. Is there any doubt in this? Okay. Next one, a digital circuit designer wishes to construct 2-input NAND using 2-input NOR gates. What is the minimum number of NOR gates required to achieve this logic? Okay. So this you should basically know from semiconductors that we will be discussing tomorrow, that if this connection of NOR gate gives us AND. Okay, so it should be like we will connect one more OR so that we will get NAND. Okay, this is the case. So how many NANDs we are using? 4. So answer is option C. Minimum we need 4 NOR gates. Is it clear? Okay. Next one. A metal of wire of length L and cross-sectional area A is connected to a battery of fixed EMF V. Drift velocity of electron is Vd. Wire is stretched uniformly double its original length connected to the same battery. New drift velocity will be. Okay. So here what we are using is that I is equal to NEA Vd. Okay. Equation for current. Then for finding Vd we can use Vd is equal to I by NEA. But the thing is we don't know current. So current we can find from Ohm's law, that is equal to V by R. Now we can see that R is there, resistance. Resistance is dependent on length. So R equal to rho L by A we will substitute. So V into rho L NE. By A will come, so A will get cancelled. From that only we can understand it is not going to depend on area. So only length is doubling. If length is doubling, what will happen? Vd will reduce by 2. Okay. Is that clear? Okay. Next one, 4 statements are there. For frequency above threshold, photoelectric current is directly proportional to intensity of incident light. That is true. Second one, saturation current is proportional to intensity, whereas stopping potential independent of intensity. That is also true. Third one, above threshold frequency, maximum kinetic energy increases linearly with frequency of incident radiation. That is true. Last one, photoelectric emission is an instantaneous process. That is also true. These are the basic observations we see in photoelectric effect. So answer is A, B, C and D. Okay. Next one, a bullet of mass m moving with velocity v strikes a wooden block of mass 9 m at rest on a frictionless surface. Gets embedded in it. Percentage loss of kinetic energy. Okay, so this is a collision problem. Like m mass is coming, here 9m mass is there, it is coming with v velocity. Okay, after the collision m and 9m, 9m are moving together with some v dash velocity. Okay, so how to calculate it? Conservation of momentum. mv is equal to 10 v dash. So v dash is equal to 10 m v dash. V dash is equal to v by 10. So we will get v and v dash. Now see the energy. Final energy is equal to half 10 m v dash square. Okay, initial energy is equal to half m v square. Okay, substitute the value of v dash, then find the difference. You will get then you will get percentage difference. Then you can see answer is option C. Okay, next one. A wall has two layers A and B, each made of different material. Both layers have same thickness and thermal conductivity of A is twice that of B. Under steady state, temperature difference across the whole wall is 36 degrees Celsius. Temperature difference across layer A is. Okay, so this is A, this is B. It is having thermal conductivity Ka, Kb. It is given as A is having twice that of B. So Ka equal to 2 Kb. Okay, and steady state means heat flow is dq by dt is same for both. So for this one it is equal to Ka A by length L into dt, change in temperature, is equal to Kb A d dtb divided by L. Since area and length is same for both, we will get Ka into 36 minus T is equal to Kb into T minus 0. Okay, so this T temperature difference across A you have to find. Find T and find 36 minus T. Okay, answer is answer will be option B, 12 degrees Celsius. Okay, this is from conduction, thermal transfer. This question also we did in our PYQ only. You can refer to that, magnetism, moving charges and magnetism chapter. This we have done. Answer is option C. Okay, please refer to that. Here directly applying gauge pressure. Okay, so they are saying that then what is the density of liquid P? That is the question. At this point same pressure. Okay, so H of P, rho of P into G is equal to H of Q, rho of Q into G. Okay, so H of P is 10 into rho P, G will get cancelled. So HQ is equal to 30 rho Q. As you can see, rho P by 3 is equal to rho Q, which means density of P is greater than of Q. Is that clear? Okay, next one. Should we stop now or complete the whole questions? It's time 11:30, that's why I'm asking. Should I solve? Okay. Next one, an object is placed at 30 cm in front of concave mirror whose focal length the image formed will be. Okay, focal length is 10 cm, concave mirror. So radius of curvature will be 20 cm, which means object is placed beyond C. Okay, beyond C we will get an image which is diminished, inverted and real. So answer is option C. Okay, this is how you relate to it. Next one, which one can be used to produce a propagating electromagnetic wave? So accelerating charged particle creates electromagnetic wave. Okay, if a charge is moving with constant velocity, it is electric field only, there will be no magnetic field. Okay, next, accelerating chargeless particle, so it will not create electric field, so answer is accelerating charge. Okay, see, as you can see, once we crossed 35, all the questions are easy. Initial questions were so lengthy also. Next one, the mean radius of Earth's orbit around the Sun is 1.5. Mean radius of orbit of Mercury is 6. Mercury will rotate around Sun 9. So, time period of Mercury divided by time period of Earth, the whole square is equal to radius of Mercury divided by radius of Earth, the whole cube. This is Kepler's third law. Okay, direct application. Since answer is in years, don't substitute in 365 days. Write it as 1 year. Then calculate. You will get answer is option C, nearly 1/4 years. Do you have any doubt in this? No. Okay. When viewed normally, the bottom of a container filled with transparent liquid appears slightly raised due to, that is, apparent shift. Apparent shift happens due to refraction of light. Option A is the answer. Okay. See, these and all, you don't need any calculation also. So that's why I said skip to the easiest question first. Do solve that. You will gain confidence. You can solve others easily. Next, 42. In a single slit diffraction experiment, first minimum is observed at angle of 30 degree with a light wavelength 500 nanometer. Width of the slit is. Actually, the same question we did in PYQ in wave optics chapter. You guys were not joined because of KCT exam. Okay, in this diffraction experiment, A sin theta equal to n lambda. This is criteria for destructive, like dark band. Okay, this is criteria for dark band or minima. Then theta is already given, lambda is given, A you have to find. Since it first minimum n equal to 1, so A equal to lambda by sin 30. Answer you will get as 1 mu. Okay, option C is the, yes, good. Next, 43. A small ball is hits obliquely a horizontal smooth surface with speed 10 meter per second. If the coefficient of restitution is 1/2, what is the speed of ball? Since it is a two-dimensional collision, we have to consider speed Vy and Vx. Vx, it after hitting also no change. This will also be equal to Vx. But this Vy is changing direction and will be a new value. Vy by Vy dash by Vy. This is equal to coefficient of restitution E. Okay, change in velocity. So from this you will get Vy dash is equal to Vy by 2. Okay, Vy by 2. From this angle 37 is given, right? So this angle will be 37 and you can easily find Vy is equal to 10 cos 37, Vx is equal to 10 sin 37. Vx dash is also equal to Vx. Then final velocity V is equal to root of Vy dash square plus Vx dash square. Okay, this is the method. You will get answer as root 52, option D. Okay, do you have any doubt? Vx is not changing because there is no force happening in x direction, only in y direction force is there. Okay. 44. Correct statement of work energy theorem. Work done by all forces equal to change in kinetic energy, no difference. So option C is the answer. Last question. Material used in construction of making standard resistant is constant and manganese. Temperature resistant coefficient of these materials are very small or negligible. Assertion is correct, reason is the right reason for it, because we need like the we need something that won't change the resistance easily. So option C is the answer. Okay, that's it. You can leave and join back for chemistry class. Thank you.